Hello everyone. The purpose of this video is to show you how to constrain a cam into the Automata box and then allowing you to manipulate the box like with the handle here, rotating the handle. Now I've actually not fully finished this one. The line, the follower is not raising and lowering, and I'll show you how to use that using a transitional constraint. But the idea is you'll be able to turn the handle and have everything rotate and have the follower raise and lower, and then we can make those measurements associated with that. So what I'm going to do is close out of this work that I was just doing here, and I am going to start making sure that my correct project folder is highlighted. So I have my Automata simulation here, and I'm going to click open, and I'm going to use the Automata simulation file here, not the test one but the simulation. Hit open. This window pops up for me because of the version mismatch. Just hit yes. And now what I'm going to do is I'm going to place a hex cam. My hex cam, this is the one I'm going to use for the test here. But you can use any of them, and I'm going to place the hex cam. Hit escape or right click and hit OK in order to get rid of the additional placing. Now you should have already followed or at least applied the appropriate work planes of this object. So there should be a mid plane, there should be a plane of symmetry, and then there should be a axis applied to the center hole. And we need those in place in order to get them to get that cam to properly constrain to this Automata simulation box. And this is how you get it to constrain. We're going to do 3 constraints to do that, and you can actually follow along. The Word document on the Google Classroom has under letter C the 3 bullets, and I'm going to do those 3 bullets, and then I'm going to jump down and do and I'll say what letter I jump to, but some more additional constraints in order to get everything working properly. So to start, letter C says add assembly constraints as follows. Bullet number 1, mate the midplane work plane. Midplane work plane of your cam, that's this dark blue work plane here. You're going to mate that midplane to the work plane that passes through the center line of the rod follower. That is this orange work plane here. Okay, so we're going to mate those two. So constrain, mate is already selected. I'm going to select this work plane and that one right there. And my cam jumps over. I get the knock noise. I'm going to hit apply to apply that constraint. So my cam has now jumped over there. The second bullet point says mate the center axis of the hole in your cam. So the center axis of our hole, that's going to be this small little yellow line, with the center axis of the axle. That's this little yellow line. So we're going to mate those two. So mate center line of the axis and center line of the axis. Hit apply, and our cam now jumps down and is basically lined up around the axis of that axle. Excuse me. The third and final bullet says mate the plane of symmetry of your cam to the work plane through the center axis of the axle. So what it's talking about is this, it's labeled here on this test cam as angle of rotation, but it is the plane of symmetry. So meaning everything on the left hand side is the same as everything on the right hand side. And the same goes then for this work plane here that goes through basically the work plane of this handle. So we're going to mate those two. So I'm going to mate this one, angle, and this one. I'm going to hit apply. Now, you should be able to, if you've done those 3 correctly, you should be able to grab this handle and rotate it. And we can see that the cam is rotating correctly with the handle. Now, it's not perfect. It's not done because the follower isn't moving up and down, and that's what we're going to move to next. That portion on the Word document is letter E. It says place a transitional constraint between the outside edge surface of your cam and the curved surface of the bottom of the follower. So this is actually kind of tricky. So bear with me here. The first time I try this, it might not snap and might not work correctly, but hopefully I get it on the first try. If it doesn't work, I found my solution is to kind of move the handle just a slightly different position. For whatever reason, that has worked for me, but I'll show you what I do here. So constrain, window pops up. We're going to do transitional. Click the transitional tab. And it said to select a outside edge of my cam. So I found the easiest is just kind of select one of these outside edges of my cam. That's right there. And then the curved edge of the follower. So that's this portion right here, but we need the bottom of it. So I'm going to kind of zoom in here and see I can highlight there. There. I'm going to hit apply. See, it doesn't like it. So my solution has been sometimes I kind of just turn it around to some different orientation for whatever reason, maybe like this. We'll try that. Constrain, transitional, this face with this bottom edge of the curved surface. Ooh, gonna be difficult, I see. Let's try it in the different direction. Curve to outside edge. Ha! Okay, so try that. Okay, we're learning as we're going. Curved edge first, and then the outside edge. For whatever reason, that seemed to work. I hit apply, and boom, it works. So now, I grab this handle, and check that out. My follower is bouncing and following along with the cam. Awesome, 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 awesome. Now, a couple things. As we're doing this and what we're moving towards, this box that's here is kind of annoying and sometimes in the way. So what we're going to do is, if you don't already have this browser window available, you can open it up by clicking View, User Interface, and then Browser right here. But we want that browser window open because we're going to do a couple things. One, we can open and close all these things. This box right here, you could right click it and you can click uncheck mark visibility, and it disappeared. This is a lifesaver when you are trying to see inside things, and I can still operate everything nice and easily here. Because what you're going to be doing as you scroll down in that Word file, you'll see that letter G then asks you to make a couple changes here to the way way certain things are visible. So I'm going to walk you through what those are. Letter G, insert an angle constraint to help you measure the angle of rotation. This is what our goal is. We are actually going to be measuring or setting defined angle of rotation between this vertical axis of symmetry and then actually one that's hidden right now, a different one. We're going to actually like preset angles, and we're going to set this cam at specific angles. So right now we could say like this is 0, and then like, you know, this would be 90. So what's at 45 and what's at 180 and so forth. You can actually fill out a data table, and you can see that towards the bottom of the Word document. I want you to either make a Word doc or write this in your notebook. You're going to make that data table for all 4 different cams. All 4 cams, the pair, the eccentric, the hex, and the snail cam. You're going to do that for all 4. Okay? So, in order to be able to do that, here's what you have to do. Letter G. Bullet number 1. Rotate your cam and orientate it in such that the follower is in its lowest position. Okay, for this example, this is a great place to start. Turn on the visibility of angle of rotation work plane associated with the follower part. So the follower part, remember I mouse over it, and look at that on the left hand side. It's highlighting what I'm highlighting. Like, it's glowing, and it shows on the browser window highlighting in red follower 1. So we're actually going to expand that by clicking the little arrow, and it said to turn on the visibility of angle of rotation workplane. Angle of rotation of follower. So right now it's all grayed out. You're going to right click it and you're going to click visibility. Now we can see this dark blue angle here. Alright, it's basically in the same plane as what this plane is for this hex, this line of symmetry, because we're actually going to measure the angle, like as like one rotates, we're going to be able to measure what that angle is between the two. Like they're both vertical up like this, and we're going to measure what that angle is. We're going to actually set it to certain ones. Okay, that was bullet number 1. Bullet 2, turn off the visibility of mate with midplane workplane associated with the follower. Mate with midplane of the cam. Right click, turn that off. Alright, basically we're just turning that off. Okay, that was mate with midplane right here. We're turning that off to make it easier for you to identify what you're clicking on. Bullet number, oh sorry, that was bullet 3 technically. Bullet 4, turn off the visibility of midplane workplane of your cam. Okay, the cam down here, here's my cam. Sorry, of the midplane. So this, mine is labeled as workplane. I'm going to right click that and I'm going to turn off the visibility of that. Alright. So that was the midplane one, the one that intersected, like cut it in half, not vertically in half. I left that one in there, but of the from face to face. Finally, it says place a directed angle constraint with a value of 0 degrees between the cam angle of rotation and angle of rotation workplane. All right, gets a little confusing, but all we're doing is we are going to say, hey, listen, this plane and this plane, I want an angle of 0. I want them to be like, you know, this would be 90. I want them at the same angle. So it's like adding another constraint. So to do that, the assembly tab, constrain, and the angle part, that's this type right here. Type, angle, and then the very specific type of angle, you have to click directed angle under the solution here. So that was under the assembly, the type is angle, the solution is directed angle. Now it automatically, if I were to click constraint and I click angle, it's clicking this one, the explicit reference vector. That one's automatically highlighted. That's not what we want. We want this directed angle one, so you have to select that. And we are going to select this plane and this plane. All right? This plane and this plane. I get a knock noise. Great. Apply. All right. Now, I cannot crank and turn the handle. That is on purpose. We can't do that because we have fixed those planes together by angle on purpose. Okay? So the idea here is you cannot move it. Letter H tells you to test and try it. You cannot move it. Now, let's say I wanted to change it, like letter I now says, okay, well, can you edit the angle to 45? Guess where that angle you can edit is? Right here. Double click it. Edit the dimension. 45 degrees. Hit enter. Automatically change the angle. Look at this offset. This to this is 45 degrees. Let's try 90. Sweet. Let's try 120. Sweet. 180. Okay. 0. Oops. Did I mess up? Oh. Oh, because it's this. Oh, I think I might have accidentally did something. There we go. I hit Alt-Z. There we go. Sorry. I had did something else. I knew I had struck a key on something. I think I was changing something else between two of them. But so make sure you're clicking on things appropriately. So there, angle of difference 0 degrees. So what you're going to do is you're going to collect data related to all of these. Now, in order to do that, you are going to be measuring how much the follower raises and lowers at these different angles. So you have a data table. It says angle of rotation in degrees. You're going to define that. Use kind of some of the more obvious ones, but you're going to want to go all the way around for this cam. So keep that in mind. You know, you could do maybe 0, 45, 90, and so forth. And then it says height of top of follower and the radial dimension of cam, or height of the bottom of the follower. So in short, excuse me, in short, what you're going to do is you can actually use the inspect tab here, and there's this distance measurement. And it's like, okay, what do you want to measure? Well, I want to measure from the top of this follower, top of this follower to maybe right here, 0.75. All right, so at 0 degrees, that distance, maybe the height of the top of the follower, some known value, is 0.75. Okay, well, now let's change the angle to 45 degrees. Okay, now you saw it just kind of jumped a little bit. Let's measure that distance from here to here. All right, same value. Try 90. Here. This is being difficult for me. It's not measuring what I want it to measure. Oh. Okay, sorry. So yeah, I must have been misclicking. So you got to be careful on your clicks. Make sure you are scrutinizing the values and the measurements that you're getting. Make sure you're getting the right values. So you're going to make those height measurements, and then one of the other things it says to do is to measure the radial dimension of the cam, or height of the bottom of the follower. So if you make a measurement from this center point to where the bottom of that follower is, that is a radial measurement, and that one is 0.05. So let's change this to 45 just to show an example how that changes. So distance, so here's this center dot to there, 0.4 or 4.461. Let's try 0 degrees, distance from that center axis to there, 4.444. So that is the other value you're going to be recording. You're recording what this radial distance is between those, and you need to find another measurement, however you choose. But I like to. There should be a way for you to measure from the top of this cylinder to the top here, so you're getting basically like a vertical measurement height change. The other thing you could actually do is maybe you could do from this axle line to the top here. That might give you a better value, a better measurement point. Yeah, that seems to work a little bit better. Yeah, so maybe that's a better way to actually measure the height of to the top of the follower. So whatever you choose to do, make sure you do it the same, because they'll basically scale, and we're going to be plotting that and creating some motion graphs, and we'll see how these cams create motion graphs. And the idea is then eventually you are going to make a motion graph and then make a cam based off of that motion graph. This is where we're going to come full circle. Like we're going one way and creating motion graphs based off of our designs, and then we're going to create designs based off of our motion graphs. So hopefully that has helped you understand what you're going to be doing when you create the motion graph. I mean, it tells you to put it in Excel. It would be great if you did that, because you could put all of that data into Excel and have it calculate and create those graphs for you, and then you can print those graphs and put them into your notebook. However you choose to do it, whether you're hand drawing all that out or using Excel, use Excel, it's going to be a lot easier. You need to be able to make those data tables for each of those cams and make the graphs for each of those cams. Truthfully, I would say 1 or 2 cams maybe before the holiday break. And the next week after that, we should be able to finish up all the cams. So hopefully this video will help you in getting the cams working. Good luck.